but yes, we will also try to keep a broad view on the applications where all of these sits in terms of the financial markets, etc. So don't be afraid of this. There will be probably no equations or almost no equations, but a bunch of computer science concepts like hash functions, for instance. But yeah, so I hope you will not get bored with all of these technicalities. Instead, I hope that you will get excited and will, go out of this room with a very good understanding of what blockchain is, what Bitcoin is, what Ethereum is, what stable coins are, etc. Especially the second part of the lecture, we will move away from Bitcoin and we start talking more about decentralized finance, smart contracts, stable coins, decentralized exchanges. So let's see what we can cover here. Okay, before I start, maybe I would like you to, tell me a little bit about yourself, so maybe we can start from this table. So, just briefly what your role is in the company, etc.
I'm an actuary, so I'm confronted with a lot of equation mathematics. Yeah. So with Bitcoin or blockchain, I have no contact.
Okay, so good point. It's important for me to know where you stand in terms of Bitcoin and blockchain. What about you?
I work in international programs, so absolutely no affiliation with blockchain, not personal, not working wise, just interesting in the technology behind it as well.
Okay, thank you.
I work in underwriting, finite underwriting. In my current role, I don't really have any contact with blockchain technologies, although I have been thinking about NFTs. So in the art market context, I've been kind of confronted with the concepts.
Okay, so maybe later we can discuss a little bit about that.
Yeah.
I also have some stories to tell about NFTs and the art market. Okay. What about you?
I work at the financial processes and operations on the group side, and there I don't have any contact with blockchain, but I audited a company of wealth manager in Zurich, and they have launched a fund based on crypto. And yeah, it was very special and because they need the license from the FINMA, and so it was a very huge project.
May I ask you what's the name of this?
Crypto assets. Let me have a look, because I think they changed the name in the time.
Okay.
Yes.
Thanks.
Good morning. I'm a financial consultant from Hanover, Germany. I so far had any contact with blockchain itself. We had a company in the insurance industry in Veos. They named a program Rita blockchain, but I think the technology behind was not blockchain, was this ledger technology, and this was too expensive. But this, on this level, is the only know-how that I have so far.
Okay, all right, thanks.
I work in marine underwriting, and so far not really any contact with blockchain technology.
Okay, all right.
I work as a partner manager, so profession-wise, I do not have any relation to blockchain and so on. It's just personal interest, a few small investments on my side, so yeah, that's just all about it.
Okay.
And a few Bitcoins.
Would have been nice.
So I do work in the claims department. I'm responsible for governance and process excellence within claims, but no connection to blockchain in private or corporate life now.
Okay, thanks.
I'm currently the chief of staff working for AXA XL, and I don't have any touch points with blockchain or crypto there, but also invested a little bit, not a few Bitcoins, but a little into crypto market myself.
Okay, all right. So yeah, thanks all of you for this brief introduction.
It's crypto finance.
Oh, sorry.
Crypto finance.
Okay, I know. Yeah, so if I understand it correctly, basically none of you have big experience with blockchain, big exposure to this topic. So we'll try to keep it as simple as possible. And I really encourage you to stop me at any time. So whenever anything is not clear, please ask a question or just tell me, can you repeat that, so that we make it a bit more interactive, which is best for everybody. Okay, so let's start with blockchain. So what a blockchain is a digital distributed technology, or DLT in short. So in other words, it's kind of a shared database system. Okay, so it's a database that is synchronized across multiple copies, so multiple servers holding the same data. And importantly, this is achieved without any central authority. Okay, so there is no third party that is needed to certify that the data is a good one, it's integral. And also, this is another very important property, that once the data is stored into this database, is recorded there, it can never be modified or deleted. Okay, so a blockchain or a DLT is a system with basically these properties. Okay, so I hope you understand what I mean by multiple synchronized copies of the database. Okay, so imagine that you have this database file with all your entries, and you don't have just a copy on a single server, but rather there are many servers holding a copy of this data. And of course, this makes it a bit tricky, right? Because whenever you want to add a record to this data, you need to make sure that this record is added on all the copies, and all the copies are synchronized. So we will come back to this. Of course, this is kind of easy to achieve if you have a third party making sure, that all the shared copies of the database are the same, but without a central authority, this is a bit trickier to achieve, and we'll see how blockchain solves this problem. Okay, but now let's take a step forward and let's talk about the modern banking system. So we may say that this is based on a digital centralized ledger. Okay, so this is not a decentralized kind of database, but it's a database which is held by a single bank. Okay, the bank may have a backup copy of this data, but fundamentally the bank, is responsible for this data. So people trust the bank to, record the transactions in a fair way and not to mess with the data of the clients. So theoretically, also in practice, it is possible for a bank to modify historical data. Okay, and let's say, there is some money is being stolen by a malicious party. The bank may decide to roll back these malicious transactions. Okay, so the bank has the power to do whatever she wants with this data. However, people trust the bank not to do anything, weird or strange with this data. But importantly, you need to trust the bank. Okay, so you need this third party, let's say, to certify that the data is correct and it's not being modified. If we want to be a bit more precise, actually the banking system is composed of multiple banks, right? And every bank has kind of its own ledger with all the transaction data, the accounts, holding, etc. And banks talk to each other to exchange this data, and they kind of trust each other. Okay, so each bank is responsible for its clients' data integrity, and there is this trust among banks. Everything is kind of correct. Now, this system has been working for many, many years. So arguably, it's a good system. It just works. But there are some drawbacks, vulnerabilities. So first of all, since the bank has the power to alter the data, this may actually happen, right? So even though you trust the bank not to do it, potentially the bank could alter its client's data. So for instance, this may happen if the government asks for it. Okay, so the government may say that particular person is considered a terrorist, so all the banks are called to freeze the bank accounts of this individual. Okay, so this may happen, and you may say, okay, this is a good thing, actually, right? But it depends, on what kind of government we are thinking about, what is the geopolitical situation. So, a person may be considered a terrorist from the US, but it may be considered kind of a hero from Russia or China, let's say. So it's all a bit relative. Another risk is the hacking risk. So it may be the case that the hacker is actually able to breach into the bank security and alter the record or steal some money, let's say, from bank account. Or it could be just a bug. Okay, so the IT system may fail because of a bug, because of a problem, and this could lead to the loss of money or some headache for clients. And last but not least, it may actually happen that people lose their trust in the bank, and then the so-called bank run happens, right? So if people don't believe that the bank has enough money to pay all of its debt, then people may lose trust, and this may lead to a collapse of the banking system, or in most of the cases, to an intervention of the state, right? So if the situation gets very bad and we have a bank run, then usually the state steps in to bail out the bank and to save the system from a collapse. But this is, arguably a problem of this centralized system. Okay, now let's talk about instead a different kind of technology, which is the blockchain ledger. And it is basically a distributed ledger, so it's a digital distributed ledger. So the only distinction from the previous example is that this is distributed, this is decentralized. It doesn't require a third party to function. And in principle, this ledger, this database, may contain any kind of data, any kind of transactional data, or even something else. We'll talk about it more later on. So distributed means that there is no central institution, and actually this institution is replaced by a network of computers that work together following a specific protocol. Okay, we will see what the Bitcoin protocol is, so how these computers actually work together to make it function. So we will focus in this first part on Bitcoin's blockchain. So that's historically the first example of a blockchain. So actually the person who came up with this idea, Satoshi Nakamoto, is actually a mysterious kind of individual. So again, we'll talk about Satoshi later on in the discussion. But what is important to know is that at some point he released a white paper, okay? And this paper was about blockchain technology. So he explains what a good protocol could be for a blockchain to achieve these properties wanted by a good digital distributed ledger. And then at the very end of the paper, he says, by the way, the first application of this concept could be a digital currency. And he calls it Bitcoin. So Bitcoin is actually just, an example, just a primitive example of what a blockchain can do. Of course, the Bitcoin blockchain became very famous and very valuable, but we will see that there are nowadays different blockchains which are much more powerful than the Bitcoin blockchain, but they are based on these ideas. Do you have questions or comments so far? Okay, so I will move on. So this is the network as a representation of the network. So we have multiple nodes, and think of a node as a computer running a specific software 24/7, and each computer has a copy of the shared database. And each of these computers is also called a miner. We will see why this terminology applies and makes sense. So what happens when a user makes a transaction? It will actually contact one of these nodes, okay, automatically to transmit his transaction. And then the node will update the database, the ledger, and will broadcast the information to all the other nodes. Okay, so let's say I make a transaction hitting this node here, and this node will transfer the information to the neighbor nodes, and those in turn will transfer it again until the transaction is recorded on all the copies of this database. So it's a peer-to-peer kind of update system. And it's important to notice that these transmissions are not immediate. So there is some delay in the order of milliseconds, but even like seconds, and this is called latency. So think of these nodes in different places around the world. Okay, so maybe one is here in Switzerland, another one is in Japan, another one is in China, in the US, Hawaii, whatever. So it may actually take 1 or 2 seconds for a signal to travel through the network. Okay, so starting from Switzerland, then maybe it moves to Italy, then it moves to the US, then it moves to China, but it takes a while for the signal to really get everywhere. Also because all of these computers are constantly listening for transactions, but not in a continuous way, right? So maybe they check for new transactions every 50 milliseconds, whatever. Okay, so this adds up to create a bit of delay. So this is important because this will create a problem, which is a double spending problem, and we will see how the blockchain technology actually solves that problem. Okay, so some people have this idea that it is actually possible to move from a centralized banking system to a decentralized one. So meaning moving from a system when banks operate with these digital centralized ledgers to a system where everything is based on a decentralized ledger like a blockchain. Okay, so actually this idea has been around for many decades, and especially researchers in computer science tried to achieve this possibility here from a technical point of view. Okay, so to create a system that could handle monetary transaction in a decentralized way. And one of the main reasons why they wanted to achieve that is to create a currency for the internet. So a currency that is not based on a particular state, but it's like international, decentralized, and people could use this currency to make payments on the internet. However, this is challenging, and there are 3 main challenges, I argue. So first of all, we need to take care of the secure identification of users. Because if you have no centralized counterpart, there is no physical bank, it's actually difficult for the system to check your identity. Okay, you cannot just go to the bank and show your passport or, or ID card to identify yourself. So that needs to be taken care in a more sophisticated way. Then 2, the problem of ordering transactions in time in the correct way. And this is a bit tricky because of the delay, the latency I was talking about before. So it may be that a person in Japan makes a transaction, it hits the Japanese node, a Japanese node first, and then it takes maybe 2 seconds for this information to get to all the other nodes. At the same time, a person may make a transaction in Europe or in Switzerland, and from the point of view of the Swiss node, this transaction actually happened before the transaction in Japan, right? And vice versa. So Japan will get news about this transaction only later on. So, there is ambiguity on how you should order these 2 transactions. So what came first? And we will see how blockchain solves this issue as well. And then finally, the immutability of transaction history. That's the property we were referring to before. So we would like the data recorded in the blockchain to be non-editable and to be valid forever, so that you cannot change it, you cannot delete it. Okay, so these are the 3 main challenges, and today we will try to understand how the Bitcoin protocol tackles these challenges. Okay, questions so far?
What is the reason behind the movement from centralized to decentralized? Is it more a technological challenge that these guys had, or was it more against the banking system? So
yeah, I think
kind of a revolution, or what was the reason?
So why? I think it's both, but it was more on the philosophical kind of side of things. So of course, computer scientists get excited when they try to solve these technical challenges, but I think the real driver behind that was a different one. So it was, trying to solve these drawbacks here of a centralized system. And, so we will see that when Satoshi Nakamoto started the Bitcoin blockchain, he embedded in the first block of the chain a particular message that refers to the instability of the banking system caused by the fractional reserve system. And that was, basically immediately after the financial crisis, when those big banks had problems, and so Nakamoto actually explicitly kind of gives us a message that his work is aimed at solving some of these problems. especially the instability of the banks, on the banking system, and based on the fact that they don't have enough money to satisfy all of their clients, like this fractional reserve banking system. So from there, the need to create digital currency, a cryptocurrency with finite supply that you cannot really like multiply and extend. Okay, so let's start with challenge number 1, the secure identification of users. And that's actually a very easy problem to solve because there is an off-the-shelf solution. So just by relying on public key cryptography. Okay, so for instance, in the case of Bitcoin, they use this elliptic curve digital signature, or ECDSI, an algorithm. And so this is based on the concept that every user in the system has 2 keys. So there is a private key and there is a public key. Okay? So a private key may look like something like this, so a very long string of numbers and letters. And every user has also a public key. Okay, so the public key is basically the address of the user's wallet. If you want, it's like an IBAN. Okay, so if I want to send money to a specific user, I need to know his or her public address. And then there is the private key that is actually needed to perform transactions. Okay, so let's say that Alice, here A, wants to send some money to B. In order to do that, Alice has to know the public key of B, so where she's sending the money, and then she needs to have access to her own private key, because this private key is actually used to cryptographically sign this transaction here. And what is important is that then anybody else in the network or any outside observer is able to verify that this is a correct transaction. So basically, they can check that the private key was used correctly, even though they don't see the private key. So the private key is always secret and only Alice knows it. But the system allows for this verification just by relying on the 2 public keys of Alice and Bob. Okay, so anybody can verify the transaction using the 2 public keys. So this may sound a little bit complicated. Maybe I didn't explain it in the nicest possible way, but think about it in a simple context, let's say of social media, your social media account on LinkedIn, for instance. Okay, so in order to access your profile, you need to log in and you need to provide your password. So your password is similar to the private key here. So only when you're logged in, then you can make a post from your account. Okay, and in order to do this, you need to use your private key. You need to use your password. Right? So you log in and then you can make a post. Everybody else using LinkedIn can see that you made that post. Okay, so using your public key, let's say, they can check that this is a real post made from you. Okay, and even if they don't know your password, okay, but they can totally verify that the post was written by you just by using your public key. Okay, so and this is more or less what happens on any website where you log in and you have your personal identity. Okay, so is it kind of clear? Right, so in this case, like public key would be your email address or your account name, and the private key would be your password. This is basically exactly what happens in the Bitcoin blockchain. So whenever you open an account, you are given a public address, public key, and a private key. And those are generated automatically by an algorithm running on your local computer. Then you are the only person knowing this private key. Okay, so you don't get to choose your password like in LinkedIn. You are just assigned a password, and then it's your duty to store this password in a safe way. Because of course, if anybody else would see your private key, would get your private key, then they could make transactions on your behalf. In the same way, like in LinkedIn, if somebody knows your password, they could log in and write posts pretending to be you. Okay, here on the blockchain, if you have the private key, you can kind of log in and then you can start making transactions. So you can send Bitcoins to whoever you want. Yes?
Are there still two factor authentications behind the private key, or is this something which is just not common anymore for this technology?
Oh yeah, good question. So there's no mandatory two-factor authentication here. So if you have your private key, that's the only thing you need. Then of course there are some services helping you to store your private key. Okay, so for instance, you may use a digital wallet software on your computer, and there, this software has your private key. So you need to tell the private key to the software for it to work. But then you may protect this with an additional password or with biometric identification. Then in order to access to, let's say, open the software, you need to verify yourself further.
But within the wallet or within the, let's call them online banks or decentralized banks, using Bitcoin, you don't have this service on top of the private key. The private key is sufficient for
yes,
of or all of the.
Yeah, exactly. So the private key is sufficient. What I meant is that you can actually store your private key in some secure places, digital places, or even physical ones. So maybe you go to your bank and you ask for a physical safe where you put your private key written on a piece of paper. And in that case, then in order to access this safe, you need to identify yourself. So it's like an additional layer of security. Yeah.
With the private key, do you mean like the recovery phrase that we have to enter if I have a wallet?
Yeah, exactly. So actually there is this recovery phrase, which is made by, I think, 16 words. And with a single, with any of these, you can actually create multiple private keys. Okay, so once you have these 16 letters, you can create the first account, and this will have a private key. Then you can also create a second account that will have another private key, and so on and so on. So basically, when you create an account on the blockchain, you can actually generate multiple private key and like multiple wallets in a sense. Yeah.
You see this complicated private key. Is this also a kind of a higher security solution within this technology? Because blockchain is, as far as I know, far safer than the internet. Internet technology is very weak because you can easily falsify a code, a password, and then you are in. And this here, it's not possible probably because the private keys are complicated.
So these private keys are based on a 256-bit, length. So they are very, very hard to crack. But actually, I would argue most of the websites we are using also rely on this kind of technology.
Okay.
The issue is that, on LinkedIn or other websites like that, usually users choose their password, and this may introduce a weakness of the system. Okay, so if I use, my name and surname as password, then it's difficult for a hacker to guess it and to log into my account. Here on the blockchain, the private keys are really those very long strings of numbers, so it's almost impossible for a computer to find your private key, for a hacker to find it. Of course, this is true if we are talking about traditional computers. When we move to quantum computers, well, this kind of cryptographic system is not secure any longer. Okay, so quantum computers, if they are powerful enough, and many people believe that in 2-3 years from now we'll have those powerful quantum computers, then this private key can be found very easily. So actually there are some blockchains like Ethereum that are already moving to a quantum safe solution. So basically they change this part of the blockchain in order to have a quantum resistant cryptographic algorithm. But yeah, going back to what you said, I think websites look like weaker on this part, basically because there is more human intervention, so like a human choosing a password. Yeah. Other questions about this? Okay, so I think the secure identification of user is kind of solved, meaning that We have a system to create user accounts, which is safe. Of course, this is not connected to a proper identity. Okay, so I can create a blockchain account without, showing my passport, my ID card. There is no KYC procedure at all. Okay, so users are identified from a computer science point of view, from a technology point of view, but they are not, we don't know who these people are. We can see the wallet, we can see the transactions. This is important. Anybody can verify these transactions. So actually, each transaction made with this system is completely public. Okay, so if I want, I can go to a blockchain explorer and I can look up all transactions from a specific wallet. So this is super transparent in this sense, but then I don't know who is the person actually owning that wallet. So it's anonymous. Yeah.
Isn't this a little bit how shall I say? I mean, when the technology started, the technology had a very bad reputation because it was used by terrorists and all the hijackers and the bad people. So how do you see this point nowadays? Because on the one hand side, it's great, everybody can use the technology and the system, but on the other side, you have these disadvantages with these bad people and using this kind of technology. Is this still a reputation topic?
Yeah, so I do believe that nowadays criminals are not using the Bitcoin blockchain any longer because it's actually very risky for them because all of the transactions are saved and can be accessed by the public. So actually there are some companies specialized in forensic analysis of Bitcoin transactions. So they look at all the transactions and then they couple this with data from about the IP address from where the transaction was first performed, etc. And by using these methods, they can usually track where criminal money is moving. And an important thing to notice is that for a criminal, it's important at some point to convert Bitcoins into US dollars or into other real world currencies. And when they do that, they need to pass through a bank or they need to pass through a centralized exchange. And in that moment, KYC is required. So, it's possible for criminals to move funds around and hopefully they are not discovered, even though many companies have the capability to discover them. But in the end, they need to go to the real, financial system, and that's where they are exposed. So, I think it's much easier, or it's a better alternative for criminals to actually use cash, because cash is not traceable. So, if you manage to move a given amount of cash from one country to another one, then you're basically done. Then you can use some money washing kind of systems to convert this cash into legitimate money, and they are done. And it's much more difficult to track these kind of activities. So yeah, in this sense, I think Bitcoin is actually, it's not used nowadays by criminals a lot. Maybe other blockchains are used for this, but are not under the radar of authorities, etc. But yeah, whenever there is a big crypto thief or they ask for money to a company because first maybe the hacker encrypts the data of a company and then in order to decrypt it they ask for money. This ransomware attack. Sometimes the hackers get paid in cryptocurrencies, but usually that's not Bitcoin. Those are like other cryptos which are more difficult to track.
Okay.
And also,
why is it possible that the different cryptocurrencies are difficult to track? Because it's the same technology behind.
Yeah, but it may be a bit different. So they may be based on a different version of the blockchain technology. So some details may be different. And then, it's just, if there are so many blockchains around, it's difficult for authorities to check all of them. Because checking what's happening in a single blockchain has some cost. So it's difficult to scale it and to cover all the possible blockchains.
So at the end, everybody can make their own currency, cryptocurrency, on a blockchain basis.
Yeah, theoretically you could do it. This software is open source, so you can, copy the code and you start running it, but then you need to convince people to join the network. Because if it's only you running this, then it's not decentralized, of course, and even if there are just 2 or 3 nodes, it's not gonna work. So you need to give economic incentives for people to buy a computer and run it 24/7 to run your protocol. So we will see what the economic incentives are. Okay, we go on. Yeah, so this is the famous Bitcoin white paper. Okay, so here we solved the first challenge, and remember there are 2 more challenges that we solved, and those are actually solved by the Bitcoin white paper. Okay, so cryptography was very ready, nothing new, but here to solve the other 2 issues, we need some breakthrough, and this is the content of the Bitcoin white paper that was released on October 31st, Halloween of 2008. And yeah, as I said before, Nakamoto described the blockchain protocol in this paper, and then Bitcoin just as a first application of it. Yes. Yeah, and then after this paper was published and it was read by many people, Satoshi Nakamoto actually started working on the real implementation. Okay, so he started writing code, and together with other people, they managed to create the Bitcoin blockchain to start it in January 2009. So just a few months after the theory was released. And this is actually still functioning at present. So basically there were no updates to this protocol, and it has been working for many years. And actually the value of this protocol is very, very high. Okay, so there's you all know what the price of Bitcoin is, how many Bitcoins are in circulation. So the market cap is above $1 trillion. And all of this is actually running through this kind of old protocol, okay, from 2009. So who is Satoshi Nakamoto? Well, nobody knows. Okay, so that's the author of the paper. There's also an email here, a website that is owned by this guy. But we don't know whether this is a person or it's a group of researchers or the CIA or whatever. Okay, so nobody knows who Satoshi Nakamoto is. What we know is that he was actually participating in the blockchain that he created at first. And initially, whenever you would solve a new block, I will tell you what I mean by that precisely later on, you would get a lot of free Bitcoins. Okay, so let's say every time you solve a block, you get 100 Bitcoins. And then you can solve a new block every 10 minutes. Okay, and because only few people were participating in the network initially, Nakamoto basically got hundreds and hundreds and thousands of Bitcoins in the first days. And we know what the wallet address of Nakamoto is, so we know the public key. Of course, we don't know the private key, but if we check on the blockchain, we will see that Nakamoto never moved any Bitcoin. Okay, so basically his wallet is very fat and full of Bitcoins, and actually Nakamoto would be one of the richest men in the world nowadays, but he never did anything with his Bitcoin. So many people believe that Nakamoto is actually, if he is a person, he died already. Some other people believe that it's actually a strategic move, so Nakamoto doesn't want to sell off his Bitcoin because this could lead to a collapse of the network, because people kind of lose trust in the entire system. So yeah, it's a mystery. And from time to time, people claim, yes, we analyze all the emails sent by Nakamoto or all the blog posts he made, the chats, etc. And we can say Nakamoto is actually this person because they write in the same way, they use the same language, etc. But in reality, nobody knows. So it's a big mystery.
I think this was the case at the beginning of this year, wasn't it?
Yeah.
This guy from Britain, or how was it called?
I don't remember his name, but he's a guy heavily involved in the crypto business. And people claim he's actually Satoshi Nakamoto. But, this happened many times, and we would never be sure, probably.
He refused to be.
Yeah.
And what do you think?
What I think?
Yeah.
It's I'm not sure, but I think he was actually a person who had this idea and he started this project. and then probably was afraid, so he didn't want to have a central role in the project, because everything is about decentralization here. But then if you identify yourself as the creator of the system, the guy who holds more Bitcoin than any other wallet, then you have this point of failure, this centralized kind of entity. And Nakamoto really didn't want that to happen, so he decided to stay anonymous. That's my, yeah.
I think it was also a little bit the dangerous movement here, because we had the big financial crisis in 2007-8, and this was kind of an answer to this crisis, because a lot of people said we don't trust the banks anymore. So they started this kind of other system, which can be dangerous. So if you go against the financial power in the world, which is huge, I mean, it's a huge power, and you start such a movement, you could live quite in danger, I guess.
Yeah, I agree with you. And you may get killed. Maybe this is what happened. So maybe that's why we don't hear from Nakamoto anymore, because he was killed by somebody. Yeah. But for sure, you put yourself in a difficult position. I agree. So even if you don't get killed, but maybe, there are other softer ways for big banks to make you, close the project. But yeah, it's a fascinating thing. I think it's still a mystery. Some people think it was like an alien kind of being, because the concept of blockchain is so complicated and it's difficult, to imagine that a single person came out with this idea. So, but I mean, of course, it could be just a group of people or just a guy having a breakthrough idea. I mean, that happens all the time in science, after all. Okay, so let's have a closer look at the blockchain. So why is it called blockchain? Because it's a chain of blocks. Okay, so every block here is kind of a file in a computer, and it contains a number of transactions. Usually there is a maximum number of transactions. So for Bitcoin, I think that's around 2,000 transactions per block. And then these blocks are all connected together. Okay, and they are ordered in a certain way. So here we have block 5 connected to block 6 and connected to block 7. Okay, and every block contains different transactions. And let's say if I want to know the total amount of money held in a wallet, I need to accumulate all of the transactions. Okay, so I see this wallet, send Bitcoins there, then you receive some Bitcoins, etc. So I need to accumulate across all the chain up to the latest block in order to know the balance of a specific account. So as I said already multiple times, every node in the network has a copy of this chain of blocks. Okay, it's exactly the same copy. And in order to understand how this chain is constructed, we need to understand the concept of hash functions. Okay, so that's a kind of a technical thing, but you will see it's very easy to comprehend, actually. So let me do this quickly too. Okay, so cryptographic hash function is basically, a function, let's call it h, that takes any input, any digital input, and converts it into a fixed length string. Okay, so here in this example, for instance, if we apply h to the input hello world, then this would be the result. If we apply it to an array of 4 numbers, okay, then this would be the result. And you can imagine, you can take any file on your computer, you apply h, and you always get such a string with a given amount of digits. Okay, and all of these are kind of random looking. So given the input, it's very, very difficult, if not impossible, to predict what the output will be. Okay, so it looks like random. It's actually a deterministic function, meaning that if you apply it 2 times to the same file, to the same input, you would get the same output. And the output is called the hash of the file. So actually, you may do this with any given file on your computer. So even a video, like a 2 gigabytes video, you can give it as an input of the hash function, and it will spit out a hash like this. So of course, this hash does not contain all the information of the original file. Okay, it's actually far from it, but it's just kind of a unique stamp representing the file. Okay, using a specific hash function. In order for these hash functions to be useful, they need to satisfy 3 properties. So first, the avalanche property, meaning that if you change a very little bit in the input, the output should change completely. Okay, so in this case, the cat is on the table full stop as this hash, while the cat is on the table exclamation mark as this completely different hash. Okay. Then it should be efficient, meaning that it should be very fast to run, you know, in the order of billions of operations per second. So this function should be very, very fast. And finally, non-invertibility. Okay, so if you are given the hash h of x, then it's basically impossible or totally unfeasible to find x. Okay, even if you know that x is a specific kind of thing. Okay, so of course, if x is a YouTube video, I would never be able to retrieve the YouTube video by looking at the hash because there's not enough information, right? Simple. But let's say that instead the input we know it's a string of 10 numbers, then it would be possible in principle to take the hash and go back to this string of 10 numbers, but it's actually unfeasible, meaning that the only strategy you could use to do this, to reverse engineer, let's say, the hash function, is brute force. So the only thing you can do is to try all the possible sequences of 10 numbers, for instance, and then at some point you would find the right one. Okay, so you take all the possible inputs, you apply the hash functions to each of them, and then at some point you would get a hash, which is the hash you want to invert, and then it would be done. But this would require kind of millions of years to do this random guessing. Okay, I'm not sure it was actually clear on this one. Fine. Okay. Cool. So in order for a hash function, and there are many around, to be a good one, they need to satisfy these 3 properties. Okay. And then a specific hash function, it's not important which one it is now, but it's a good hash function, is used on the Bitcoin blockchain in the following way. So basically we take as inputs all the transactions in the block and another special string, which is called the nonce of the block. I will tell you more about this later on. Then the hash of the previous block. So this is a recursive kind of procedure. And then you get a hash, okay, which represents this block. And the blockchain protocol actually requires this hash to start with many zeros. And we'll see why this is the case and what it means. Okay, so every block has an associated hash to it, which is created using a specific hash functions and taking in these pieces of information. Okay, so again, this means that if we apply the hash function to this block again, we would get the same hash. Okay, so this is a deterministic kind of linkages. And also, because this is a good hash function, if we change any single transaction here, okay, even like instead of Alice sending 10 Bitcoins to Bob, we say Alice sent 9.9 Bitcoins to Bob, then the hash of the block would change drastically, completely, because of the avalanche property. Okay. So this is the hash function used by Bitcoin, SHH 1056. It was designed by the National Security Agency, actually the NSA. That's why some people believe Nakamoto was a member of the CIA, because it chose this specific hash function. The reality is that, you know, most applications, websites, etc., they actually use this kind of hash function. So it's the most commonly used one across a variety of use cases. So there's nothing special about this. Okay, questions about this?
Could we also use, I mean, this is cryptocurrency or crypto, how do you say this in English? Cryptographic technology. Usually used by the militaries because they have encrypted messages, I think, all over the systems.
Yeah, sure.
Could you also use this kind of technology, for example, nowadays? We have a lot of fake images, for example. Could you also use this kind of technology to verify the origin of a picture, for example?
Yeah, I think so. This is being used actually. So I think pictures generated by AI have a watermark. Sometimes it's visible, sometimes it's not, and this is a hash of the image with a specific hash function. So you can actually check that that image was generated by an AI. I don't know the details, but I'm sure that this is actually used there. All right. So other questions about this? Hopefully everything will become more clear once we put the pieces together. But now you know what a hash function is, and you know how it is actually applied to Bitcoin's blocks. Okay. So now every block has its own hash. Okay, block 5 has hash 5, block 6 has hash 6, etc., etc. And these are kind of unique identifiers of the blocks. Okay, so every block has its own hash, and this identifies the block in a unique way.
But when the transaction change in the blockchain, then also the hash change.
Yeah, exactly. So that's a very important point because it's basically the main idea behind the protocol.
But
so you cannot change transactions in the past because if you change the transaction, then the hash would change, and this would have a chain reaction across all the blockchain.
Okay, so then the blockchain has different hash, and it depends on the time where it's blocked. Like there was 10 transactions, and then there were 20 transactions, and then you have a new hash. Is it right?
Yeah, so I mean, it's more or less like this, but the thing is that blocks are created at discrete points in time.
Okay.
And once you create the block, you bundle a bunch of transactions into the block, you compute the hash, and the block is done.
Okay.
Then you cannot touch it anymore in the future. Okay. So the block hash is this identifier, and also each block has a reference to the previous hash. Okay, so this actually orders the blocks in time. Okay, so block number 6 not only has the hash of block 6, but also the hash of block 5. Okay, so they are all connected in this way. So they're linked sequentially. So this also gives us an ordering in time of the transactions. So we know the transactions recorded in this block came after the transactions recorded in this other one. Okay, so the key innovation proposed by Nakamoto based on hash functions is actually the proof of work algorithm. So the idea is that every block has to be solved by a node or by a miner in order to be accepted by the rest of the network. Okay, so we will see what I mean by solve here. But it's important to note that all the nodes, all the miners are actually competing against each other to solve the next block as fast as possible. Because if they solve the block, then they get some free Bitcoins. So there is a huge economic incentive for people to try to solve the block before anybody else. And to solve a block, you actually need to find a special string, this thing called nonce, which solves a specific cryptographic puzzle. Okay, so this requires a lot of computational power. So basically all of these nodes are working 24/7, using a lot of electricity, trying to tackle this cryptographic puzzle, because they know that if they win, they will get money in form of Bitcoins. And the more hash power you have, so the more powerful computer you have to play this game, the higher is the probability that you will actually solve the next block. Okay, so these miners are actually investing a huge amount of money into new servers, and into running these servers as fast as possible. And when a miner solves a block, it gets the reward, and then it's also broadcasts the block, the new solved block, to the rest of the blockchain. Okay, so stay with me. The next slide is going to be hopefully clarifying. So the protocol requires that the block hash needs to have at least n leading zeros. So it needs to start with some given number of zeros. Okay. So each miner actually generates a random candidate, a nonce, and then it tries to compute the corresponding block hash. So now let me quickly go back. Okay, here. So I said the input of the hash function is the transactions, the previous block hash, and then we also have these nonce. Okay, so now the game is basically given the previous block hash and the transactions. Let's try any possible nonce here, and we apply the h function, the hash function. So most of the time we'll get a hash that doesn't start with zeros. We will get a randomly looking hash. But sometimes for a specific block nonce, we will get a block hash that starts with many zeros. Okay, so basically the game, the cryptographic puzzle, is to try many nonces as fast as possible, and then they always check whether they get to a lucky hash. And the first one who gets to a hash starting with many zeros actually won the game and solves the block. Okay, so that's another kind of representation. So let's say that we have two miners, okay, miner 1 and miner 2. So what they do is, okay, they are given the transactions in the block number T, so this block which is still pending, it's not part of the blockchain yet. They know what the hash of the previous block is, okay? And then the only thing they can change is this nonce here, this eta, this Greek letter. So they choose one randomly, they try to apply the hash function to these people, and then they get a hash, but doesn't work, doesn't start with many zeros. So the second miner is doing the same. Okay, so usually they're working on the same block or a slightly different version of the same block, and it randomly chooses another nonce, and it gets this hash here. Then they do it again, and think of this as happening, at the millisecond frequency. So every millisecond they actually make hundreds of thousands of guesses, and at some point, just out of luck, one of the miners will find a nonce that actually works. Okay, so for which the hash starts with n leading zeros. And pay attention, this is not the only solution to the block. There may be like an infinite amount or a very large amount of other nonces that do the job, but this is randomly the one that came first. Okay. And once the miner, the node finds one, then it can share this with the rest of the network, and everybody else can check that this nonce here is a good one. So how do they check it? Well, they take the new solved block, they just apply the h function themselves, and they check that the hash starts with many zeros here. Okay?
And the zero was chosen. Why is it zero? It could be an A or a. Why is it zero?
Yeah, that's correct. It could be anything, so it's just a choice. So actually, these hashes here can be also converted into numbers. That's a hexadecimal representation of a big number. And basically, if they start with many zeros, it means that this is a low number. Okay, so you may interpret this condition as the hash number should be below, let's say, 10,000. So maybe that's why Satoshi Nakamoto chose this thing. But I agree with you, it could be like it should start with A's and it would work in the same way.
It's always 6 numbers, or is there a minimum digit of zero?
No, good point. So there is a parameter n, let's call it n, representing the number of zeros required, and this is chosen by the protocol every 2 weeks, basically. Okay. And this controls the difficulty of the game, because if you require the hash to have more zeros, it's actually more difficult to find an answer leading to that. So think about it. If I would require just 1 0, okay, at the beginning, then it would be very easy to find a solution. Okay, so I would try some random ones, and let's say after 100 trials, 1,000 trials, I would most likely find a hash starting with a 0. It's not so rare to find one. But if I require the hash to start with 20 zeros, then it's much more difficult to find. Okay.
But what is the average time it takes to solve such a block?
Yeah, so actually Satoshi Nakamoto wanted the block time to be on average 10 minutes. And so the number n is chosen to achieve that. So the network kind of knows what is the total hash power, so what is the total computational powers that miners on the aggregate have. And based on that, you choose, the network actually automatically chooses n, so that on average a block is solved every 10 minutes. Okay, so as more and more people join the mining industry, this n is going up. So I don't have it on the slide, but you can easily find on the internet. You can find a plot of n and the hash power, and you will see that they are almost perfectly correlated. And over time, the difficulty has been increasing because more and more miners are participating into the game with more powerful hardware. Yeah.
Is the number of miners still increasing?
I'm not sure that the number is increasing. I know that recently the hash power has not been increasing any longer because many miners actually switching to AI. So instead of mining Bitcoins, they are kind of changing, refurbishing their mining farms in order to provide computational power for AI models. Yeah.
So you mentioned this is part of a game, and those miners they do this to find the hash with like a lot of zeros in this beginning, but it's kind of hard for me to imagine how that would look like, or how would they like do this. Could you give us like a concrete example? How would it work?
I mean, think about a computer running the software, and the software is just picking a random nonce here, and then it's applying the hash function to that triple, and then it checks whether the hash starts with zeros or not. If it doesn't, it will repeat this. There's kind of an infinite loop that stops only when you find a nonce leading to n zeros.
Okay, so
but it's just like a computer program, a very simple computer program running indefinitely.
Okay, and then the whole game behind is that you kind of code this computer program so good that it's pretty fast. Like that's the game behind it, or like?
No. So there is no way to invert the hash function. Okay. So there's no way that you write down this hash with many zeros, and then you invert the function to find the nonce. This is impossible because of the way the hash function is constructed. So the only thing left is brute force. So you just need to try many possibilities until you find the solution. And that's not, it is not the case that if you're better at writing software, you can do this more fast. Not really, at least. So everybody has the same algorithm to do that. What makes a difference is the hardware. If you have more powerful hardware, you can do this faster. So that's what the game is about. Yeah.
Just a question on what would happen if there would be no miners anymore, and all the miners would, for example, decide now we invest our capacities into AI.
Yeah, of course that would be the end of the blockchain. If you have no miners, the blockchain cannot work. Or even if you have a small number of miners, then it would be considered highly centralized.
Do you think that's a possible scenario for the future?
It's possible, but I would say it's unlikely because as miners quit the game, then the profitability from becoming a miner increases and increases. Right? So, if there are just a few miners, each of them is generating more Bitcoin. Right? So there is less competition, so it's actually more profitable to join the market.
And the number of Bitcoins that they gain is fixed, or it's depending on whatever?
So it is fixed temporarily, but every about 2 years, this number is divided by 2. Okay, so I think nowadays, if you solve a block, you get 2 Bitcoins, but at some point in the future, you will get only 1 Bitcoin, and then you will get only 50 cents of a Bitcoin. So this was a very important feature according to Satoshi Nakamoto. But initially, you have a very large supply of new Bitcoins. And then as time goes by, these new Bitcoins become more and more rare until basically you get 0 Bitcoins for every block. And so the total supply of Bitcoin is fixed at a given level. So in the future, I think around 2100, so in like 80 years from now, 75 years from now, we will reach this situation where miners, they don't get any Bitcoin by solving the blocks. And then they only get the transaction fees associated to transactions. Okay, so every time I make a transaction on the blockchain, I actually need to pay a little amount in fees, and these fees are collected by the miner solving the block.
Already today, additionally.
Today is additionally, so they get the new Bitcoins plus the fees.
Okay.
In the future, they will get only the fees.
And who is a miner? Are there big companies because you need a lot of power for?
Yes, so there are very big companies in the space, but most of the hash power is actually coming from mining pools. Bless you, from mining pools, meaning that there are many users, maybe with not so powerful computers, joining the mining pool, and then all together they participate into the game. And whenever they solve a block, the profits they share across all the participants. So, for instance, if I wanted to use my laptop to mine, theoretically I could solve a block from time to time, but on average, statistically speaking, it would require maybe 1,000 years for me to solve a block. Right? So, okay, I could get very lucky and solve one after 5 minutes, but that's very unlikely. So what would happen is that I would just use a lot of electricity and get 0 Bitcoins before the end of my life, right? Instead, if I join forces with other people, we can work together on this, and most likely, every week we would solve a block, and then I would not get 2 Bitcoins from this, I would get just a little amount of Bitcoins, but at least I get something. Yeah. Yeah.
So the whole thing is dependent on the Bitcoin price rising, otherwise miners don't have any.
Yeah, of course. I mean, if the Bitcoin price goes up, then miners have more incentive to buy more expensive hardware, because of course, if they solve the blocks, they get more money.
And if there are no Bitcoins left to mine, then there is only the service fee. And how high is that service fee? It depends on transaction, of course, but to have like an idea.
I mean, so every user can actually choose the amount of fees they want to pay, and then miners would prioritize the transactions with more fees attached to it. So basically, what happens if as a user you want to make a transaction, if you choose a high level of fees, your transaction will go through the next block. So on average, 10 minutes, and then you're done. If you use very little fees, then maybe you need to wait for 10 blocks. So you need to wait for hours and hours. And of course, the market may move in the meantime, so it's a bit risky. Of course, so it depends on the level of fees in the intensive margin, but also on the number of transactions at the extensive margin, right? So if more and more people use the blockchain and they are active, they make transactions, then miners are happy because they get more fees. And then maybe they invest in more powerful hardware, to meet this demand in a sense. If instead people buy Bitcoins and then they hold it as a form of digital gold, whatever, and they never make transactions or almost never, then this could be very problematic for the network.
This is currently mostly the case.
Yeah, so nowadays there are not so many transactions in Bitcoin, but still miners are profitable because they get these 2 Bitcoins every time, right? But in the future, when miners would rely only on fees, it's crucial that the network is actually used by people. If nobody makes transactions, then it's...
So Bitcoin basically needs to be commercialized, so people need to use it for payments, otherwise it will...
I'm not sure about this. I see it difficult for Bitcoin to be used as a payment system because of the high volatility. I don't know. But yeah, so we will see what happens. But, the future is doesn't look so great for Bitcoin, at least from my perspective. Other cryptocurrencies look much better. Other blockchains look much better, better fit. And there are so many transactions on the Ethereum network, for instance. Yeah.
Do we also have a blockchain students club here at the university? Or do we have students who act as minors, for example?
Not that I know. Do you think so? That's the case?
I think not nowadays, because nowadays it needs too much compute power. But I think when it started, I don't remember, but I heard of some guys who were minors just as a hobby, you know, at home. So they use their
But I heard
computers
that in Switzerland, power is way too expensive to be competitive to mine. But
Yes,
that's
and
what I-
then with the big farms, I mean, a lot of miners on China, so I think nowadays you probably have no chance.
But yeah, I mean, you need to join a pool. You need to join a mining pool, and then you get a little bit out of it. But you know, you can also decide to participate as a miner into other blockchains. So, for instance, I've been doing it with the Ethereum blockchain since a couple of years, and you get profitability around 3 or 4% per year. And you don't need a powerful computer to do that. You just need a computer which is connected to the internet almost 24/7. Okay, other questions about this? So, you know, I think this is like one of the core concepts. So if you understand this, then you better understand what Bitcoin is and how it works. Actually, there are some websites where you can see the blocks forming. For instance, this one. And pool.space. So here you see that some blocks have been validated. You know, this one 9 minutes ago, the other one 16 minutes ago, 45 minutes ago. So here you can see that the time distance between blocks is not 10 minutes exactly. It's on average time 10 minutes, right? So here you have 6 minutes. Here you have much more, and then you have 5 minutes. And here you can see the miner who actually mine those last blocks. Okay. So for instance, that's a pool for sure. I don't know about the other ones, but most likely they're also pools. And these are the new blocks under deployment, let's say. Okay, so people are actually actively trying to solve those blocks right now. And yeah, it's estimated that it will take about 11 minutes, but you know, this could happen in the next second. It's just kind of a random process.
What is sort of the investment that it takes to like solve a block?
Sorry?
Like what's the investment that it takes, like the power behind it?
I mean, what you mean is like the energy required to solve a single block?
Yeah.
Yeah, honestly, I'm not sure. I mean, it depends on the difficulty parameter. And you know, most of the times you actually use a lot of energy, but then you don't solve the block.
Mm-hmm.
So you know, maybe you solve one block every 100, and then you may say that this block costed you all of this electricity that you use for 100 times you played the game.
Okay.
But I cannot give you a figure, honestly. I'm not so much into the business. By the way, yeah. So if you click on a block here, I think you can actually see the hash. You see, this starts with some zeros. Yeah, actually many zeros. It seems like. Yeah. Then you have the size of the block, the total fees, you know, attached to this block. So you can see it's like $1,700. Okay. Yeah, that's it, or less. And there are other websites, other blockchain explorers, where you can actually dive in and look at all transactions contained in the block. So I'm not sure this is what happens if I click here. You're here. Oh, okay. But for sure, you can actually see it on other websites. Ah, okay. Here you go. So 3,600 transactions included on this block. This is the Coinbase, so the newly generated Bitcoins. It's actually 3.15 Bitcoins, so it's not 2, it's a bit more. Okay, and then you see all the transactions. Basically, you know, like specific wallet moved Bitcoin to another wallet, and here you see everything that happened within this block. Okay, so these are the transactions recorded in the block that are now. Okay, questions about this?
It's like a different world. Huh?
yeah, but like people are actually doing this, and there's a lot of money going around this. But yeah, I honestly believe all of this is not so useful, right? And it consumes a lot of electricity. So I will argue later that Ethereum is much better than this. There are many more use cases, and it also doesn't consume as much electricity as Bitcoin. Oh, sorry. Yep. Okay, so this is the number n, the difficulty. I think we discussed about this. This is updated every 2 weeks, more or less. Actually, to be precise, every 2016 blocks. Okay, because on the blockchain, everything is based on the block time. Right? So the protocol doesn't really know that 2 weeks have passed. So the protocol just knows that 2016 blocks have been solved. Okay. Yeah, so here I wrote at the moment n is equal to 19. I'm not sure this is exactly the case, but it's 18 or 20. It's in this range. Okay, so let's go back to the 3 challenges, moving from a centralized to a decentralized system. So secure identification of users, we're done with that. Time ordering of transactions and double spending, we'll see, and immutability of transaction history. So we will see how this cryptographic puzzle and all of this setup actually allows us to solve these 2 problems. I think maybe you understood it already, but let me try to guide you through it. Okay, so secure timestamps. So the problem is that there is no cryptographic algorithm that assigns a specific timestamp of a file, meaning that I create a file on my computer, this is associated to a specific timestamp, but I can always change it. So I can always kind of cheat on that. There's no way to show securely that my file was created in that specific date. Okay, that's a bit of a problem for the Bitcoin blockchain because it's difficult to order transactions, right? And whenever I create a transaction, I cannot certify that I did it in a specific point in time. So the network has to figure it out somehow. Okay, and the solution is actually based on this competition among miners. Okay, so here let's say that we have 3 miners, and then there is so-called mempool. So that's kind of an abstraction. It's a virtual place where you have all the pending transactions. So these are all the transactions made by users over the last minutes. Actually, miners can choose some of those. Okay, so for instance, the star miner is choosing the blue, orange, and red transaction, while the triangle miner is choosing the blue, purple, and red. Okay, and they choose the transactions basically depending on the fees associated to the transactions, but also depending on when they see those transactions. Okay, so maybe the star miner is a miner in the US, and these transactions are made in the US, so the miner sees those and starts working on that block. While another miner is maybe sitting on China and it sees before these transactions, so it's gonna include in the block in the next possible block this transaction, and then the game starts, right? So they start working on the candidate blocks. So the candidate blocks can be different, they can be the same, they may differ by a few transactions, whatever. It's not very important. What is important is that once one of the miners finds a solution, then the new block is added to the blockchain, and the current timestamp is also added to the block. Okay, so depending on which miner here solves the puzzle, the ordering of transaction may be different. But once the puzzle is solved, the block is solved, then the ordering of transaction is settled. Okay, it was just kind of chosen by the miner. Okay, so I mean, there's nothing special about this. It's just the first miner who solves the block actually puts those transactions in the blockchain. And so if for instance here the purple transaction was not here, so the purple transaction will be added most likely later on. Okay, so it will happen after these other transactions. Okay, so actually the timestamp is part of the block information. I didn't say it before, but it's actually part of the information contained in a block. Okay. Yeah. So the miner doesn't need to prove that you know, these transactions came before other ones. They just solve the block, and then this is you know, recognized by anybody else. Okay, then immutability. So that's the third part, the third challenge. Okay, so let's go back to our chain of blocks structure. So this is obtained by the linkages of the blocks using the hash of the block. Okay, because if you remember, the block hash depends on all transactions with timestamps contained in the previous block, the solutions of the previous blocks. And so if you change a single transaction in a block in the past, then this would have a cascading effect on all the other blocks. Okay, so let's think about it for a moment. So let's say I change a transaction here. So, you know, I'm one of the miners. I have a copy of the data set, but I decide to change a record, you know, to make some profits. Then this would imply that when I apply the hash function to this block, the new block, I will get a hash that doesn't start with many zeros. Right? I would get a random hash. In order for it to start with many zeros, I would need to find a new nonce. Okay, so this would mean that I need to play the game again, and I need to find a new nonce such that this hash actually starts with many zeros. But then this hash is also an ingredient for the next block's hash. Okay, so now the hash here is different. So this means that when I apply the hash function to this block, I'm gonna get something that doesn't start with many zeros. Okay, so I need to resolve this block again by finding a new nonce, and so on and so on. Okay, so the more you go into the past and change something into the past, the more blocks you have to resolve. Okay, in order for blockchain for the new version of the blockchain to be a good one. And anybody can check, you know, whether the new version you are proposing satisfies the rules or not, just by applying the hash function to all the blocks. Okay, is it clear? So there is, you know, this cascading effect from the old block to the newest block. You would need to resolve them again, but you know, that would take a very long time. Okay, so think about it. If you are part of the mining network, and maybe your hash power is, I don't know, 10% of the total. Okay, so in the real blockchain, everybody is working on the next block. Okay, so you have 100% hash power, and then you get a block every 10 minutes, more or less. If instead you start working on a different version of the blockchain, and you want to keep it hidden to anybody else for the moment, then you just have your 10% of the hash power to work on it. So this would mean that it doesn't take on average 10 minutes to solve a new block, but it would take 100 minutes, okay, 2 hours, let's say. So while you try to advance your modified version of the blockchain, the real version will advance faster. So it's difficult, if not impossible, to catch up. So your blockchain will always be kind of shorter than the real one. And this is why the protocol implements the longest chain rule. So basically, a node may receive different copies of the blockchain from other nodes, and it has to select only one of them. And there is this hard-coded rule that it should select the longest chain. Okay, so the chain with the bigger number of blocks. Okay. So, as I said, if a malicious user changes a past transaction, she will be unlikely able to produce a chain longer than the real one. So let's say the real one, you fork it by changing a transaction here at some point, then you need to work on this yourself Okay, and this is going to be a slow process. In the meantime, the real chain, where all the other miners are working on, is going to advance at a faster rate. So as a result, all the nodes will actually discard your chain because it's too short, and everybody will focus on the longest chain. So that's a very, very important rule in the protocol that allows, in the end, for the transaction, for the blockchain to be immutable. So it's not possible to change something in the past. You cannot compete with the rest of the network. I mean, of course, if you have a lot of hash power, more than 50% of the total hash power, then you could dream of doing this. Okay, so that's why one of the fragility of this system is the so-called 50% attack. So if a miner is very, very big and has a lot of hash power, then it may be able to cheat on the system. And then the system is not secure any longer. Yeah.
And also quantum computing will be a threat in the future.
Yeah, that's correct, because if you have a quantum computer, the quantum computer may be able to produce many more hash per second, so use the right algorithm. So basically, if you are the only one with a quantum computer, you could actually do this. So change the transaction so that you move 1,000 bitcoins to your wallet, and then you use your quantum computer to create a longer version of the blockchain with respect to the original one, and the nodes would accept it. So actually, Bitcoin is not quantum resistant at the moment, and yeah, people would need to make a change in the protocol for this to happen. So other blockchains like Ethereum are already quantum resistant, meaning that they already deployed an update in their blockchain software to handle this kind of quantum attacks. It is not active yet, but in case they see that powerful enough quantum computer starts becoming available, then they would immediately switch to this quantum resistant version of the blockchain. For the moment, they didn't switch yet because it's not super efficient. So they are still working on it to make it more efficient, but they could even do it today in case of need. All right, other questions about this? Okay, so this is about the mining pool concentrations. I mean, this is a screenshot from a few months ago, but I guess the situation didn't change much. So you see that there are some big pools, so like these F2 pools, owning 10% of the hash power. This Foundry USA, that's also a big pool, the Mara pool, etc., and pool. So if you put, the biggest pools together, they actually have more than 50% of the hash power. Okay, so if they collude, this could be problematic, right? Because maybe from the outside they look like different entities, but if there is collusion, that they are kind of the same, and that they could work on the same, edited version of the blockchain, and they could perform this 50% attack. There are also many unknown miners. Okay, 20% of them, at least, we don't really know who they are. Okay, so there's no real company behind it. It may be single individual, it may be like big mining farms that just don't declare themselves. Makes sense? So is it really like there the possibility of collusion? Well, I argue this is not really the case. Okay, because miners are actually rational. So they understand that if they will try to cheat the system, then most likely the price of Bitcoin would go to zero. And then it's the end of their business. And of course, miners, first of all, they hold a lot of Bitcoins. So if Bitcoins go to zero, it's a very bad thing for them. And also, if nobody wants to use the Bitcoin network anymore, then they're just out of business. Yeah.
What do we see here in terms of countries or region? I see Foundry USA as the biggest one, so a US player.
Yeah.
Then Ant Pool is probably China. Or what is Ant Pool?
So actually, a few years ago, China banned the Bitcoin mining. So as far as I know, nowadays, it's legal to have a mining company in China.
Okay.
Of course, those mining companies, they move to neighboring countries So you may say, you know, physically they are now away from China, but it is as if they were still in China.
Okay, so perhaps Vietnam or Singapore.
Yeah, exactly. Yes.
And then F2 pool.
I don't know where that is from, honestly. For sure, we could Google for it and find the answer.
Because it's quite interesting. It looks like a US, China, or Asia game. I think Europe is not in the game here. It's quite interesting from a geopolitics view.
What I know is that many miners actually try to act in a region where they have a lot of renewable energy sources, because that's just cheaper. So I'm not sure you were mentioning that there are no miners in Switzerland because it's not convenient. I'm not sure, maybe there is actually some miners using hydroelectric energy. Yeah. But yeah, I mean, I'm sure that there are many miners around the world, so this is quite decentralized, as a matter of fact. Then you have these big pools, and those are, I mean, there's a company owning this pool, and it may be a US registered company. But then the real hash power joining the pool may come from all around the world.
And why did China ban the miners?
I'm not sure about that. Honestly, I don't remember what was the main reason. Maybe because of environmental concerns.
Okay.
Because there was like a lot of demand for electricity, energy in general in China, and these mining farms, they were using a lot of it, so the government kicked them out. But probably there are other reasons as well.
So F2 Pool was founded in China.
Hmm?
F2 Pool was founded in China. I just Googled it.
Okay.
We're from Peking, China, but now they are gone out of China and they're worldwide. Google says.
Okay, yeah. Thanks. Okay, so, you know, I would argue that still the economic incentives actually motivate miners to stay honest, say. And also, I mean, we need to admit that this system is there since 2009, and it would be very profitable for somebody to change a transaction in the past, right, and to move 1,000 Bitcoins in their wallet. But as a matter of fact, it never happened in almost 20 years. So nobody ever managed to pull off this trick. So I guess we can conclude that the system is quite secure. It was never hacked, and it would be super profitable for a hacker to hack into the system, but nobody were able to do it yet. I mean, of course, we've heard about many crypto scams, right, over the past years, and like there are many also in 2026. But these scams are not related to blockchain technology. So usually there are hackers hacking into centralized exchanges for cryptocurrencies, and then they can steal money from there. Or there are other kinds of hacks. So for instance, they replicate a wallet software, and then let's say I buy a new laptop, I want to install the wallet software, and instead of the real one, I go to this one created by the hacker, then I plug in my private key and they steal it. This happens all the time, but it's not really a weakness of the blockchain protocol. It's more a weakness of people using the protocol and not paying attention to all the details. Okay, so we talked about proof of work. So that's the name of the algorithm that drives the blockchain protocol for Bitcoin, at least. And looking at the pros and cons, I think it's a very nice algorithm, a very nice protocol, because it actually allows us to have decentralized consensus. So this decentralized ledger technology. Okay, that's great. It achieves that, and it was not possible before. It's super secure. Okay, so as I said already, nobody were able to hack into the system. So this proves, given the valuation of the system, that this system is highly secure and resistant. However, one of the drawbacks is that it requires a lot of computational resources. Okay, so in order for the Bitcoin blockchain to function, you need to have this many miners, and each of those miners has a lot of expensive hardware. So this hardware has to be produced somewhere. When it becomes obsolete, it has to be, recycled, etc. And also they use a lot of electricity to run these computers 24/7. So that's a huge environmental impact. And you may argue that all of this is worth nothing, right? So just to power this digital currency, we are using so much electricity, we are using so much hardware. This is kind of nonsense, you may argue. Some other people instead are more positive about this. They say, okay, Bitcoin is an international kind of service. Everybody from around the world can use it. It's totally decentralized. It's a nice technological innovation. So it's okay to use energy to run it. But how much energy actually is used? Well, the last estimate was about 61 terawatt hour per year. So this is comparable to the electricity consumption of Switzerland. Okay, so it's a lot, right? Now, if we want to be objective about this, we have to say that Switzerland is a rather small country, right? Even though it's a rich country, so we're using a lot of electricity in Switzerland. But Bitcoin is a worldwide available service, okay? And also we need to pay attention to the words because this is the electricity consumption of Switzerland, but it's not the energy consumption of Switzerland. Okay, so electricity is just a portion, maybe like 20% of the total energy consumption in a country. Okay, so everything that comes from oil, coal, etc., is not accounted here. So it's we're just looking at electricity. So if you consider this, maybe the amount of electricity that amount of energy that Bitcoin uses is like a quarter of the energy used by Switzerland. This may be a more honest statement, but it's still a lot. Okay.
Is it really decentralized when you need to go to the bank at the end to get the money out of it to be part of the normal market to buy a real estate or something like that? So the technology itself is decentralized, but you need to go to the bank at the end to get the money out of it.
Yeah, I mean, it's not necessarily the case, meaning that some people actually sell a house payable in Bitcoin. It happened many times that actually people bought a big villa using Bitcoins. This is possible. Okay. And also, for instance, there are many e-commerce websites where you can pay with cryptocurrencies. So even Galaxus here in Switzerland, the Amazon equivalent of Switzerland, allows you to pay with Bitcoins, Ethereum, or stable coins. So in that case, you don't really need to go out of, I mean, you don't really need to go to the banking system. You can just, use your Bitcoins to buy some. But I see your point. I mean, I agree with your point.
Because I think it's not, at the moment, you can't live without real money in the world. You need money at the end for something. You can't do anything by Bitcoin or by a blockchain technology on the market.
Oh yeah, you're right. So for instance, I have some cryptos and then I subscribe to this crypto.com app service and they also gave me a credit card. Mm-hmm. So now basically I can use my cryptos to pay using a credit card. But then it's not decentralized any longer because I need to rely on this crypto.com intermediary. So,
and they earn money because they give you a credit card and they convert it to the real currency.
Yeah, exactly. So they convert my cryptos into Swiss francs, for instance, and then they charge 5%. Okay. It's not very convenient, actually. Okay, but so proof of work here is not the only alternative. Actually, there are also alternative consensus protocols. So like proof of stake or proof of burn. Proof of burn is kind of an old idea now, it's not really used anymore, while proof of stake is widely adopted across many blockchain providers. And I mean, I guess you understand why this is called proof of work. Work here refers to this computational effort that you have to make in order to prove that you that you worked on it and you solve the block. Here instead, the proof of integrity is going to be based on the stake. So on how many cryptos you're actually owning and staking into the system to show that you have a skin in the game. Okay, before talking about it, let's look at the Bitcoin dominance. Okay, so even though Bitcoin is the oldest blockchain and arguably it's the less efficient and it is the less functional, there are not so many use cases, etc. It consumes a lot of energy, everything we talked about. Still, the market share of Bitcoin is above 58%. So meaning that most of the value in the cryptocurrency market actually comes from Bitcoin. And that's the most expensive cryptocurrency and the highest by market capitalization. Ethereum here in blue nowadays has a share of about 10-12%. Okay, so it's like the second cryptocurrency by market capitalization, but it's far from the level of Bitcoin. And also we have many other blockchains. So altogether, they represent about 25% of the total. Yeah, does it add to 100%? Yes, I think so. Yeah, and recently we've seen a rise of stable coins like Tether, USDT, or USDC from Circle, or Binance USD. And if you look at them, the total market capitalization of these stable coins, they actually sum up to about 10%. So this was 9% nowadays, it's actually 10%. Okay, and we will talk about stable coins. So stable coins, usually they don't have their own blockchain, but rather they are represented by smart contracts on some other blockchains. We try to explain this to you. Okay, so now I think we still have 15 minutes. So I would like to start talking about Ethereum, this alternative blockchain, this second crypto asset by market capitalization. But before I do that, do you have any other comments or questions about Bitcoin and blockchain in general? Yeah?
I'm not quite sure, but perhaps we could make a break here before we go on.
Yes.
Time-wise, but it's up to the class.
Yes.
What do you think?
Right.
Nino needs a coffee, so let's do it.
So I totally agree with you.
Let's do a 15 minutes break and then we continue. Huh? For those who have to check out.
Also ich bin auch.
CAS.
Ich
Ich kann das einfach eingeben.
Mir geht's gut, wenn meine Chef
Ich habe auch schon Ethereum. Dann kannst du das einfach. Warum nicht? Einfach mal zu gucken. Manchmal. Das ist nur mein Konto für Spiele.
2 Wochen alt.
Ich habe einfach gesagt, ich will manchmal wissen, wie sich so Märkte verhalten.
Die ganze Zeit weg und sie ist allein.
Technisch anders gelöst.
Überfordert, wenn sie 5 Uhr abends anruft und sagt, komm bitte nach Hause. Arbeiten.
Maybe 50% for them.
Let's check when I can.
Cash.
Also ich habe zusammengestellt mit einer Freundin.
Wahrscheinlich nicht so viel Lauer.
Hat Kinder, die hat Zwillinge. Und die sind zusammengezogen, als sie knapp 1,5 Jahre.
We need a coffee, Andrea.
Yes.
Ich habe aber, also, sie hat erfahren, dass ihr Freund sie betrogen hat,
I live in
als die
Zurich.
Kinder knapp.
Okay.
This morning I had to wake up quite early.
Okay.
Und dann bin ich halt jede Woche 2-3 Mal bei ihr geblieben und habe halt sie irgendwie unterstützt mit den Zwillingen. Das heißt, so 7 Monate alte Kinder sind kein Problem. 3 Wochen alte Kinder, so. Und vor allem will ich sie ja halt irgendwie unterstützen. Aber ja, ich sage jetzt, ich kann zumindest Montag rein und Dienstag, ja, Nachmittag wahrscheinlich. Ja. Das ist mir jetzt schon irgendwie wichtiger als da irgendwie Physio für mich, wenn ich da gar kein Schulterproblem mehr habe.
Ja,
Also Montag kann ich auf jeden Fall suchen, ja. Du hast noch keine Freundin, die Mutter sind oder enge oder eine deiner Schwestern oder so? Nee.
Also eine heiratet.
Ja, nee, ich habe sogar ein bisschen
Ja, so schön der Reihe nach. Heiraten? Kinder?
Ja, genau, nee, so machen die das. Auf jeden Fall.
Magst du auch raus?
Ja.
Ein bisschen stehen.
Schon gibt.
Also die plant und dann kannst du mal gucken, wie die das machen.
Genau.
Bisschen ab.
Eine Freundin hat
der Kollege von Hof, der am Schluss nicht, dann wird es nicht, aber wenn die auf die Uhr können, das geil.
Nino, Ingolstadt.
Ingolstadt, das hat der Fjord
Das aber nicht mehr, keine Ahnung.
Ja. Meinst du?
Das war so 2014.
Oder was ja.
Ja, wir haben schon gemeint, aber das Server gibt es dann halt nicht mehr. Da war das $200. Ich weiß nicht, wie viel nochmal 5 oder 7 keine Ahnung, was wir mit dem gemacht haben. Wo das Server nicht
Mach zu Hause mal selbst. Ingwer, Zitrone, Hummus, Pfeffer,
Ja, ganz crazy ist so. Ja.
War der Fjord zum Rotbuch.
aber krass, also ja.
Sonst hat es da noch Gurken Minze, Nino. Ja, alle nicht.
Ja, Apple, es ist ja, wenn du, also jetzt zum Beispiel, ich habe sicher schon genauso wie viele iPhones gehabt, schon genug. Wenn du jedes Mal, wenn du ein iPhone kaufst, hast du den gleichen Betrag in Apple investiert, hast du den ersten Netflix-Pass mit dem Das ist schon crazy, wenn du so überlegst, oder? Weil eigentlich ist es, ja, einfach stehen am Ende mit der vier kaufen, wenn du erst einen Geburtstag haben, oder? Das sind, finde ich, shady Leute, die kein iPhone besitzen.
So they really it's not a message.
Aber damals so durch Technologie, ich hatte mal ein Apple.
Jetzt schon dann Apple-Fan. Ich bin ein riesen Beste.
Aber wie sagt man? Ein Jünger?
Ich finde auch nicht ein Klischee-Spiel, wo keiner schreibt. Ich finde so was ist komisch.
Ja, aber weißt du, ich habe immer bei irgendwelchen
Also gerade die heimischen Musikboxen sind sogar von Apple, also dass sie halt dann alles noch nicht
Man Apple will das Auto produzieren, aber ich brauche
Ja, schon der Programmierer, schon in Agenturen,
ich alles drauf.
Ja.
Ich alles Boxen die heim.
was die Leistung auch bei Deutsch.
Also Smartphone-mäßig, alles Apple. Aber ja, eigentlich ist es dumm, oder? Das ist so. Das System, also das Ding ist halt schon, ich finde es rein von Software, also spezifisch nicht Software, sondern das Betriebssystem, finde ich so unglaublich benutzerfreundlich. Und ich habe einmal so ein Spot in so einem Android-System, ich habe fast einen Herzinfarkt bei groß. Und nach 9 Monaten kann ich das iPhone ja, das ist so gut alles verbunden. Das macht das Leben einfach so beeindruckend.
Also Online-Banking von meiner Frau. Ich bin einfach, da weiß nicht. Und diese
Das ist nicht das
Ich habe einfach so viel Schrecker. Der Aufwand, ja, ich kriege das
Hier schon, wir haben nochmal 1, 2, 3 mehr gehabt. Ich habe noch einen Gin-Coil in der Keller. Das crazy.
Stimmt, das muss jetzt sein.
Ja, also das ist ja gut.
Das Thema ist halt, nur Weine, also so ja, genau. Wenn du mit allen kommst, das hier rein und um 19 Uhr dann kannst du da bestellt kein Mensch rein. Und dann haben wir die Mossstube direkt dran und deswegen von der Hagel direkt die Mossstube anstellen. Und da ist dann aber jetzt weiß ich, dass ich bestellt habe. An dem Donnerstag.
My predictions are usually we'll see. I'm not quite sure. I'm a little bit pessimistic.
Ja. Und die Kurs hat alle, das ist ja bei allen machen.
I don't trust them all.
Du musst schon das sagen, ich sehe, ja, du musst mal, die sind nicht weg. Ich habe versioniert, ja, die sind alle abgekommen, der Kiko, der Gall, und das ist alles so mega alle angestanden, gell? Dann ist der Eindruck aufgestanden, das ist der Tag, wo Kiko war. Und dann hat man schon gecheckt, so, aha, die haben einfach gewartet, aber Kollege, was Scheiße ist, da macht viel mehr. Die sind aber alles so angeschaut, so Trainingsfilm im falschen Film und so, ist Scheiße. Ja, wir haben nicht gemacht. Nein, definitiv nicht.
And then we have
Niemand was anderes sagt, weißt du was?
who's arguing too big to fail.
Wann sind wir dann,
So something will happen.
wann sind wir wieder da?
Die haben Montag frei. Also, weißt du, immer wenn bei uns die Jungs montags gehen, haben sie wieder was vor. Das ist halt wirklich ein bisschen so richtig.
We'll see. It's a very interesting.
Wenn alles ready ist, dann ist noch Swiss Casino, dann da gestern die los, gell? Ich so, nein, was hast du da hoch gefragt?
Sehr lustig. Hätte man mal auch sehr lustig gesagt.
If you have an American view, go in. So, what's the time-wise? Okay, everybody ready? You ready to rumble? Ready to rumble? Yes.
Und dein Meeting ist gut gegangen?
Oh, ja, ist okay.
Das ist du nicht.
Es gibt nur Arbeit zu tun. Ja.
All right, so welcome back. I hope the coffee was actually useful. For me, it was for sure. Okay, so in this second part, we'll move from Bitcoin. We'll start talking about Ethereum and decentralized finance. Okay, so Ethereum is one of the first cryptocurrencies actually. So it was created after Bitcoin in 2015 actually. So this is 6 years after Bitcoin was created. And the leaders were Vitalik Buterin and Gavin Wood. And what is special about Ethereum is that it allows for smart contracts. Okay, so we will talk more extensively about it. But the idea is that the creators of Ethereum actually created also a new programming language called Solidity. And this is a Turing-complete programming language, meaning that you can achieve basically any software capabilities using this language. So what's the idea? The idea is that we have Bitcoin blockchain, and it works for monetary transactions. Okay, so those records that you have in the database are about people selling Bitcoins or receiving Bitcoins, and that's it. The idea with Ethereum is to expand the set of transactions that are recordable on the blockchain. Okay, so not only monetary transactions, but also basically calling functions of specific applications. Okay, so if I interact with a smart contract with a decentralized application, then the interaction would be saved on the blockchain. Okay, so there would be a record of the blockchain that my account actually used that specific decentralized application to do this and that. And all of the state variables associated to this application will be saved on the blockchain. Okay, so this is a much larger set of potential transactions that we can record on the blockchain. But the basic infrastructure is the same. Okay, and actually when Ethereum was launched in 2015, it was based on proof of work. Okay, so the same algorithm from Bitcoin with little modifications. One of those modifications is that you can actually save these more complicated transactions in the chain. But the basic idea is exactly the same. Let me try to put this back to work. I think I need to restart it. Yeah. So recently, actually in 2022, the Ethereum blockchain was updated, and it was updated to move to proof of stake. So we'll tell you more about this, but basically it doesn't use proof of work anymore. So still, it's very similar to the Bitcoin blockchain, but it doesn't consume as much electricity. We'll see how that's possible. Okay, so in proof of work, we know that these miners have to solve new blocks, and this requires a lot of computational power. So that's what happens in Bitcoin. With proof of stake, instead, like miners are required to post some stake in their account, meaning that in the case of Ethereum, they need to buy some ethers, and then they need to stake those ethers, so to lock them in the system. Okay, and the more ethers you have locked, the more likely you are to be selected as a validator for the next block. Okay, so in proof of work, the probability that you solve a new block depends on the hash power that you have. Okay, the more power, the higher the probability. Here instead, there is the pseudo-random election process. So the higher the stake you have, the higher the probabilities to solve the next block. Okay. Yeah, so nodes actually stake some ethers or some coins into the network, and then the election of the next block proposer is based on the node's stake size, as I said, and then there is a random component. Okay, so it's actually tricky to achieve a real randomness in this context, but if you click on this link here, RANDAO, you can read about how this is done. But that gets quite technical. By the way, in general, every time you see this color on the slides, and I guess you have the slides already, or otherwise I will send them to you. But these are links, so if you click on those, it will open a web page with more information. Okay, so as I said, nodes with larger stakes have higher probability to solve the next block. Okay, so the system doesn't rely on this competition among miners anymore. But what are the incentives? Well, first of all, these staked coins, the locked coins, can be slashed. So basically, if a miner doesn't behave properly, it doesn't follow the protocol, then the staked money will be taken away. And also, it is the case that as with proof of work, if a miner on the Ethereum blockchain has more than 50% of the staked amount, then the system would not be secure anymore. Okay, so this 50% attack still persists in this context. But for a valuable cryptocurrency like Ethereum, actually having 50% of the staked amount would be extremely expensive. It would require a huge amount of money. So for instance, Bitcoin has a market capitalization of actually more than 500 billion. Jeff Bezos is worth $125 billion. And the number of, total value of the staked ETH Ethereum is more than $50 billion as of June 2023. So this means basically that Jeff Bezos would need to invest, half of his capital in order to have 50% staked on it. Okay, so that's a huge amount of money. And also, everybody could observe this, right? Then the entire system would lose credibility. Most likely, Ethereum would go to zero or almost zero, and so Bezos would lose a lot of money on this. So it basically makes no sense to try to achieve more than 50% of the stakes in the protocol because of economic incentives. Okay, so let's have kind of a historical view on proof of stake, how it developed. So in 2014, actually Vitalik Buterin, so one of the creators of Ethereum, and it's kind of a famous guy, he really looks like a big nerd, and you saw him sooner or later. And still nowadays he's very involved in the development of the Ethereum blockchain. But in 2014, he wrote, after years of research, one thing has become clear. Proof of stake is non-trivial. Okay, so back in the day, Ethereum was still running on proof of work, and researchers in the Ethereum Foundation, they were trying to find a way to move proof of stake. And there are many little details that you have to consider in order to be sure that the system is safe and efficient. And then it adds so non-trivial that some even consider it impossible. Okay, so in 2014, even though the Ethereum Foundation was working hard to achieve proof of stake, they were not sure it would be possible in the end. Okay, so that was still like a very uncertain kind of progress. But then, in September 2022, they actually successfully upgraded to proof of stake, and this event is referred to as the merge, because basically there are two chains merging together. So basically they made it. So after almost 10 years of research, they were able to figure it out, and they moved to proof of stake. Okay, so how it works is that this is the old proof of work blockchain of Ethereum. Okay, and at some point they added a new blockchain which is parallel to it. Okay, so this Beacon chain, and then at some specific date, that was in September 15, 2022, they merged these two blockchains. Okay, so the proof of work blockchain and the Beacon chain merged together, and then we have this proof of stake blockchain. So actually nowadays we still have two blockchains. So now, one is about the execution layer. So it records the transaction and figures out what is the output of these transactions. And the other one instead just tracks the validators. Okay, so that's that. So it just keeps record of which node actually approved every block in the chain. Okay, and this was actually big news in the financial press back in the day. Okay, so when Ethereum managed to pull this off, Financial Times, Bloomberg, New York Times actually wrote about this as a very big thing. Okay. And this is what happened in my mining software when this happened. So back in the day, I decided that I will start mining once the system would move to proof of stake. because proof of work, of course, I didn't have enough computational power to participate meaningfully. But a few days before the switch to proof of stake, I actually started the Ethereum software on my computer, and I was ready, to start mining once proof of stake was introduced. And this is the message I saw. You see on September 15. So as planned, proof of stake was activated, and they have this two pandas for some reason. Okay, but from here on, okay, I started actually validating blocks on my computer. Okay, so from time to time, I would be selected as the creator of the new block, and I would post it to the rest of the network, and people would certify that it's valid. In most of the time, actually, my system is just validating blocks recorded by other nodes. Okay, and this is profitable. So I make about 3% per year. Okay, so it's not a huge deal, but it's something. And this profitability is accrued in a non-linear way, meaning that most of the day you make almost nothing. Okay, maybe you make just $1, whatever. And then when you get lucky and you are selected by the pseudo-random process to create a new block, then you get quite some money. Okay, so maybe hundreds of dollars on that specific day. So from time to time, every 2-3 months, you are selected and you get lucky in this sense. So to participate, I had to provide some stake. Okay, so the minimum amount required is actually 32 ethers. So that's like a substantial amount of money, but my stake is there, and whenever I want, I can withdraw it. And since I always behaved honestly, because I'm just running the software, I didn't modify the software or anything, my staked money was never taken away. Okay. Yeah?
Is it running on a laptop or on a stationary computer? And
so
is it always on the internet?
Yeah, so it's actually working on a server, but this is always connected to the internet. So, in practice, I have a friend who's a web developer, and sometimes he's actually hosting the websites he develops, and we use one of his servers to run this.
Okay.
But actually, it uses maybe 5% of the computational power of the server. So I could also run it on my laptop. The only problem is that I would need to make sure that my laptop is always online, which is, of course, impractical. And actually, it happened that this server was down for some reasons, maybe because I didn't update the software, for instance, and then it stopped working. And then, you just don't gain money while the server is not online, but also you don't lose money. So, even if you're not connected 24/7, you could still do it. Okay. Other questions about this? About proof of stake? I hope it's kind of clear. So let me tell you a bit more about the consensus protocol here. So actually, blocks on Ethereum blockchain after the proof of stake upgrade are organized into epochs of 32 blocks or slots. Okay, and the time between a block and the next one is only 12 seconds. Okay, and it's not on average 12 seconds. It's actually always exactly 12 seconds. And basically there are 32 blocks here, and so 32 nodes are selected as proposers of the new blocks. So those are the guys that get lucky and are selected. And then all the other nodes basically act as validators to propose blocks. So every node is actually, in one epoch, is always a proposer or a validator. So if you are a validator, you get almost nothing to do that. Instead, if you are a proposer, then you get more money, and the actual amount of money that you get depends on how many transactions are recorded in the block. Okay, so for the easiest blocks, let's say you get more money. Okay, so this I will skip it. I just want to say that there is an equivalent of the longest chain rule, but here it's slightly different. It's called the heaviest chain rule. So basically, if a node receives two versions of the blockchain, it would favor the one with more validations. Okay, so where most of the other servers actually voted for it. Okay, so now let's talk a bit more about smart contracts. So in a way, a smart contract is a distributed computer program, or a software application, which is deployed on the blockchain. So by deployed, I mean that the code of the software is recorded on the blockchain, and all the state variables of the software are recorded on the blockchain. Okay. And as I said before, these are written in Solidity, which is a Turing-complete programming language, so we can achieve virtually anything we want with this programming language. So technically, a smart contract is also an account on the blockchain, so it has a public key. Okay, so every smart contract has its own address, and whenever you want to interact with the application represented by the smart contract, you need to submit a transaction to that address. Okay, and that's public. But a smart contract is different from a wallet account because the smart contract doesn't have a private key. Okay, so basically the smart contract cannot start any transaction on its own. You always need a wallet with a private key contacting the smart contract to make a transaction. Okay, so the smart contract is kind of there, dormant, and whenever somebody is interactive with it, things happen. But you cannot do stuff like, every day the smart contract is doing this, or every hour is doing that. That's not possible. You always need a user interacting with the contract explicitly. As with other transactions, I mean, every miner actually stores a copy of the contract, so of the code. And actually, whenever you create a new smart contract and you send it to the blockchain, this is saved as a transaction. So it's a transaction, it's called a smart contract creation transaction. And the data of the transaction includes the code, the source code of the contract. Okay, so basically, whenever people interact with the smart contracts, miners make the calculation to understand what's the output of this interaction. On Ethereum, whenever you want to call a smart contract, interact with a smart contract, you actually need to pay some fees, and this is referred to as the gas. Okay? And the amount of gas that you pay is proportional to the computational complexity of the function you are using. Actually, it depends on how much data you're writing on the blockchain. So I can actually call a smart contract to ask for a specific state variable. So this is kind of a read-only mode, and then it's free of charge. If instead I want to write some data on the blockchain, because maybe I want to update one of these state variables and save it to the chain, then I have to pay for it. And the more space I'm using on the block, the more I have to pay. Okay, and miners are compensated by pocketing this gas.
So is it possible to change the blockchain when you have a contract and then you need to adjust something on the contract, or do you need to create a new contract?
Mm-hmm. Yeah, so it's not possible to change the smart contract. Okay. It's immutable as the other transactions. So if you want to upgrade your application, you just need to create a new smart contract.
Okay.
And then if you make it in a smart way, you may have kind of a contract that relies on other contracts. Mm-hmm. So let's say you have a contract representing your application.
So it's like an appendix or like an updated version.
Yeah, I mean, so you can have one variable in the contract that points to another contract. Okay, so you would have the public key of the first version initially. Then when you release the second version, the global contract would change the value of this variable to point to the second version.
Okay.
This is called a proxy contract. Mm-hmm. So you can actually update it in this sense, but physically you need to push another contract to the blockchain.
maybe as an example, maybe it helps our companies. I don't know if all of our companies, but most of them had a, I don't know how it's called, maybe a foundation or something like that, where they tried to build a system where you have the history of a car. So when it is bought, how much kilometer it had, and all the data in it, and that changes over time. But this is stored in the blockchain, so you can't. There's no possibility of fraud or anything else because you have a clear history and what happened to this car. But I think it was stopped a few years ago.
Okay, so people were not using it.
Yeah, it's, I don't know, 5-6 companies have to agree on one process and everything of it. I think that didn't work that well. I don't know, you can look that up if you want to.
I remember I read about this potential application. Then I didn't know that somebody actually did it. I read in the past that Porsche was going to do that.
Yeah. It was AXA, and so it was in Switzerland. It was AXA, it was for sure Zurich. No, which other ones? Yeah.
Okay, by the way, we will see some other applications of smart contracts down the line, but I can already tell that the biggest application is stable coins. Stable coins are represented by a smart contract. Okay, so I think I already said this, yeah. So the contract can be changed. And usually the creator of the contract is set as the owner of the contract. And maybe the creator has some additional capabilities. I mean, they can call some functions that are only limited to the owner of the contract. So, a smart contract is a decentralized application, but this doesn't mean that it's fully decentralized. So depending on how the contract is set up, you may have different level of centralization. So if you have the creator of the contract with special capabilities, of course, then you need to rely on this entity to behave in the proper way. There are some smart contracts that are totally decentralized. So people create them, but they don't set themselves as the owner of the contract, and then everybody has the same rights on the contract. Okay, so a very important smart contract template, standard smart contract, is the so-called ERC20 standard. Okay, so it's a very basic template for smart contracts on the Ethereum blockchain, and it's totally open source. And this is used to create tokens on the blockchain. Okay, so whenever you want to create a token, you just need to deploy a version of this ERC20 standard. So again, think of it as a template. And this template has to include these 6 functions here in order to be considered compatible with the ERC20 standard. Okay. So it's not here because it's not actually necessary, but usually when you create such a contract, you set the name of your token. Okay, so let's say I want to create my personal token, I can call it Andrea, and then on the contract it will be like token name equal to Andrea. And then I need to make sure these functions are here. So the total supply is a function to check how many of my tokens a specific wallet actually holds. Okay, so as an input to this function, you need to pass in a wallet address, and the function will return the number of tokens held by the address. Okay, so that's how the ownership of the token is tracked in the system. So it's just a state variable in the contract. Sorry, I was wrong actually. This is the total supply, so the total number of existing coins, and instead the balance of is this function tracking the balance of a specific wallet. Then you have the transfer function. Okay, so if you want to give your tokens to somebody else, you use the transfer function. And of course, you need to specify the number of tokens you want to transfer and the target address. Okay, so actually these 2 functions, total supply and balance of, are so-called read functions. So whenever you access those, you're not writing any data on the blockchain. You're just reading data. Okay? So they cost nothing. Instead, if you want to make a transfer, you actually need to write some data on the blockchain, because basically you have to say, if I transfer 10 tokens, right, my account would have 10 tokens less than before, and the target account will have 10 tokens more than before. And so this is data, this is a state variable that you need to write on the contract, on the blockchain, and so it costs some money to that. Then you also have some other functions that are, they allow other people to do transfers for you, etc. So that's useful in the context of decentralized exchanges, for instance, but let's not cover that. Okay, so this standard is very important. It's also used for stable coins, which are specific tokens, but it's also used to create governance tokens, utility tokens, etc. And the nice thing is that because they all have these functions, they can be integrated in multiple wallet applications, etc. So for instance, any exchange like Binance can easily integrate these tokens because they satisfy this standard. Okay. Just to make it a bit less abstract, if you want, I will click on this link. Okay, and here we can see the code for this smart contract template. Okay. You can see it's not such a huge thing. It's like 300 lines of code. And basically here there are the implementations of all those functions and more, actually. As you see here, you have transfer from, approve, allowance. This is the transfer function, right? And you see you specify the address, the target address, and the value that you want to transfer. And then just call another function. This is the balance of function, the total supply function. Okay. So it's just a template. It's like a text file containing some code, and you just modify it. So you set what is the total supply you would like to have, the name you would like to have, how the transfer works, etc. And then you can publish it. And then you submit it to the chain. But it's nothing more but this code here. Yes, for instance, that's the name, but you can change that the symbol, the trading symbol, but you can change in case you want to have one. Okay, do you have questions about this? Okay, so this is like a super simple application, decentralized application, that basically keeps track of a specific token and who are the owners of this token around, how many tokens exist, etc. Okay, so that's the main application. Okay, stable coins. So for instance, Tether, or also called USDT, it's a stable coin back to the US dollar. So the value is supposed to be always $1. And the market capitalization is actually, sorry, this is an old slide, but it's actually now about 200 billion US dollars. And the daily volume is amazing. It's crazy. So nowadays, it's in the order of the hundreds of $billions per day. So this particular ERC20 token is widely used. It's widely adopted by people. And actually, the smart contract is deployed on the Ethereum blockchain, but also on other blockchains. Because we have to say that Ethereum is the leader in terms of smart contracts, meaning that there are more smart contract interactions on Ethereum than with all the other blockchains. And also, Ethereum was the real innovator here. So Ethereum actually proposed this standard for smart contracts, the Solidity programming language, etc. And nowadays, almost all the other blockchains are just a copy of Ethereum. Okay, so they use the same programming language. And this in particular means that if you have your smart contract for an ERC20 token, with one click, you can deploy it to all the blockchains that support the Ethereum standard. Okay, so use exactly the same code. And this is what the guys at Tether did. Okay, so now they have the stablecoin on Ethereum, but also on at least 10 other blockchains. And they didn't need to write any new line of code to achieve that. Okay, then there are other standards. For instance, this one is for NFTs, non-fungible tokens, but I guess I will not go into this right now. But you told me that you have some experience with NFTs. non-fungible tokens?
Well, yeah, I looked into them, but yeah.
Okay. By the way, I mean, if I can say something about NFTs, basically they are an extension of the ERC20 standard. So it's also a standard to create tokens, but these times the tokens are not fungible, meaning that two tokens are different from each other. Any two tokens are different from each other. Or another way, every unit of the token is associated to a unique ID. Okay. So while for ERC20, so like a stable coin, any unit of the stable coin is the same as the other one. Okay, and it's not identified by any ID. Here is that every unit is identified by a specific ID. And this is useful, for instance, if you want this token to represent some digital artwork. Okay, so let's say you have an artist that produced 100 different paintings, and you want to create some NFTs representing paintings or digital paintings, let's say. And then you would create an NFT with 100 units in total supply, and each token will be associated to a specific work from the artist. Okay, but I will not talk more about this now. So maybe if you want, before we move on to more advanced topics in decentralized finance, I can show you how the smart contract of Tether actually looks like. So let me sit down. Okay, so here we have the link. So now this link opens the Ethereum Blockchain Explorer, or one Blockchain Explorer, let's say. I hope the font is big enough so you can read a little bit. Okay, so that's the address of the USDT contract. So that's the public address. So this means that whenever I want to interact with this contract, I need to submit a transaction to this address. You see, the same contract is deployed on 19 blockchains. Okay, so that's highly deployed around. What do we have here? Yeah, the name of the symbol is USDT and the name is Tether USD. And then you have the transactions here. So you see that there are 340 million transactions, okay, since the contract was created. And actually there are right now 25 pending transactions. Okay, so most of them are the transfer, they call the transfer function, okay, to basically to move the stable coin from one address to another one. And yeah, I mean, you can see that there are so many. So if I reload the page, make the connection works. Now there will be some new pending transactions. Okay. Maybe we can look at, I can filter, I think, for completed transactions. Okay, so this one was appended to a block 70 seconds ago. Okay, so this is the hash of the transaction. Every transaction has a hash, unique hash. And here we can see that this guy here, this wallet, actually interacted with the stablecoin smart contracts to make a transfer. Okay, and so basically he moved 125 units of the token from his address to another address. Okay, so pay attention, there are 3 wallet addresses involved here. Okay, so the first one is actually the sender, so the guy who triggered this transaction. Then the second one is the receiver of this transaction, the guy who got the 125 USDT. And then finally, there is the address of the contract. Okay. So actually, this guy here made a transaction to the contract in order to achieve this transfer. Okay, so here we can see more about the transaction. So the gas paid, for instance, okay, so it's 0.12 units of gas. So this is basically like a few cents of a dollar. And here we can have more details on the transaction. So you see the function that was called, it's a transfer function with the address and the value. We can decode the input data. So we can see that this is the guy who received the money, and this is the 125.1 units of the token. You see that this is an integer number, so you need to divide it by 10 to the power 8 to get the actual amount. Okay, so that's an example of a transaction. We can also see the block. So this is the block where the transaction was recorded, and it has 2 block confirmations. So meaning that this was approved 3 blocks ago. So if now I reload the page, most likely we have more block confirmations. Okay, so now it's 13, and of course, the more blocks you have after your transaction, the more secure your transaction is. It's more difficult for a potential malicious user to go through the blockchain again. And there's also the timestamp. Okay. So now if I click on this block, I can see all the other transactions contained in the block. Here. So this block has 500 transactions or something, and these are all of them. Okay, so most likely these are transactions involving stable coins or similar things. Okay, because I see a lot of transfer transactions here. Yeah, basically all of them. Okay, but there's a lot of activity. So for each block, there are many transactions that are recorded, and most of them are actually interactions with smart contracts. So now, if we go back to the USDT smart contract here, that's still the transaction. Okay, so that's the USDT contract. Well, first of all, we can look at the code of the contract. Okay, so if I click here, then we can see the code. Okay, so if I want and I know the programming language, I can actually check that this is a good code that does what it's supposed to do. But it is public, and actually it is usually audited by external firms to check the integrity of the contract. And of course, this one cannot be changed in the future. Okay, then I can
what
also...
kind of contracts are in there? Because I don't get the clue why I need to have a smart contract.
I mean, so Tether wanted to create this stable coin, and they did so by deploying a smart contract. Now the smart contract handles all the transfers, all the balances for this stable coin.
And why I need a stable coin?
Well, stable coins have many use cases. For instance, think about international payments.
Okay.
So it's very expensive to do international payments from one country to another one using the banking system. With stable coins, you can do it basically free of charge. Okay, so here we saw the code of the contract. We can also go to read contract. And this exposes these read-only functions. Okay, so for instance, we can check the name, that's Tether USDT. We can check the total supply. This is the number of units in circulation. Okay. Yeah, we can also check the balance of a specific wallet. Okay. So for instance, I have my crypto wallet here. If I go to the network Ethereum, yeah, actually I don't have any stable coin here on this one. But you know, this is a wallet with multiple accounts. So maybe I go to DeFi course, I have something. No. Okay. So here on this wallet, I do have some Tether USDT. Okay, so $8 worth of them. So theoretically, if I copy my address here and I paste it here, okay, then it should give me the amount that I own. Okay, so you see it's 8.18 cents. Okay, so this is a read function. I can call it free of charge, And basically I can check what is the balance of the stable coins for any wallet, my wallet in particular, but for anywhere. Okay. So now let me switch back to this other wallet, DeFi course. So here on Ethereum, I don't have any stable coin. Okay, not any Tether coin, let's say. But what I can do is I can copy this address and I can send some stable coins to this address. Okay, so now I move back to my other wallet where I actually have some Tether USDT. And now I just hit send. Okay, I paste the address from my other wallet, and then I have to specify the amount. So let's transfer maybe 2 units of USDT. I hit continue, and now my wallet is asking me to sign this transaction. Okay, network Ethereum USDT, blah blah blah. So I will transfer 2 USDT to this other account. And now when I hit confirm, basically my private key will be used to sign this transaction. Okay? Confirm, now the transaction is submitted. Now I need to wait for a miner to pick it up and to put it into a block. Okay, so on Ethereum, it's a new block every 12 seconds. So you can see now the transaction is confirmed. Okay, so now if I go here to the smart contract, I can check my balance, and now it should not be 8.18, but 6.18. And you see that's the case. So this state variable was updated in the contract, okay? And now I have less USDT as before. While if I go to my other wallet address, this one, now you see that I have my 2 USDTs. So how does my wallet know but I have 2 USDT? Basically, internally, the wallet is calling this function, okay, to check how many USDT I have. Right, so now I can also take my address and here in the blockchain explorer, I paste it in. So I can see all of my latest transactions, okay? And this is the last one. So 1 minute ago. Okay, so this is my transfer, right, of 2 USDT from one address to the other one. Okay, so I can monitor all of my all transactions here. Everything is completely public. Okay, do you have questions about this? I hope this example was like a bit enlightening. So now you understand better how this works. Okay, so let's go back to the slides now. Okay, so now we can use a new set of slides actually. Okay, so now we are officially at the second part of the course. So how much time